All right. What's going on, pre-calculus? I gotta admit, I'm a sad man today. My Titans lost last night against the Bengals. This was our year. We were going to the Super Bowl. We got Derrick Henry back, and we blew it. The only people who can probably understand how I'm feeling right now are Packers fans, because you also blew it. And I say that with no malice in my heart, because I'm just a broken spirit today. And then later that night I found out that the house that my wife and I put an offer on, because we're trying to buy a house, we got outbid. So we lost it. So it was a double whammy Saturday for me. So I'm in pain, but I'm ready to talk math here. Okay, this video, remember, is going to be short, about 15 minutes or less. And all you have to do to get credit for this assignment, this is your homework assignment for tonight, is send me an on-campus message with, submit this in the comment section on the assignment. Don't send me a message. Submit this in the text box. Type 2 things that you learned from the video. 2 things that you learned. And don't just put the first 2 things I say. Like, actually watch and do this. It's good feedback for me. And then 1 question that you still have. And we'll try to start class with some of those. Okay? Because the point of this is Tuesday is going to be all practice. So here you go. There's 2 parts to this video. The first part is I'm going to get you ready for your quiz. Just talk linear functions, just recap. But then we got to start moving into other function stuff. So first 5 to 6 minutes is going to be us talking linear stuff, which will be most helpful for the quiz. And then I want to just remind you of a couple other characteristics of functions, because functions travel with us all semester long. You'll have them in calculus. Like, we need to know the properties of functions. So since I'm sad, I'm just going to make up a table here that is going to be a linear table. So let's rock with this. Let's say that the x variable is going to be, let's say I'm going to drown my sorrows in donuts. I love donuts. They make me happy when I'm sad. I don't know if you've ever been to a Krispy Kreme. Those were big down in Tennessee. Krispy Kreme, when that hot and ready sign comes on, I could crush a dozen of those. No problem. So number of donuts is going to be our x variable. Okay, that's our independent variable. That's what kind of determines the y variable. And y variable obviously is going to be money spent. Okay, I got to buy the donuts. So there's going to be a direct linear correlation, a constant rate of change between how many donuts I eat and how much money I spend at the donut shop. Okay? So let's just make up some numbers. Since the Titans lost, the lowest that I would even eat would be 4. I think 4 donuts would be the lowest I would eat. And that would cost me $10. So then we'll just start it there. Maybe I eat 5. Maybe I eat 6. Maybe I eat 7. Maybe I eat 8. Who knows? And then we can finish with 10 or 12. Maybe I go the full dozen. Okay? So I know it's unusual to normally count by 1 and then jump up, but as long as you know that I just pointed that out, we're good. So there's my table. We know that this is a linear table because the rate of change is constant. Notice, from 4 to 5, it increased by $2.50. 5 to 6 increased by $2.50. 6 to 7 increased by $2.50. 7 to 8 increased by $2.50. 8 to 10, that jumped up twice, so $2.50 plus $2.50 is $5. So it all works. Okay, this is a linear relationship. Okay, and I'm going to use this relationship to answer some questions. What if on the quiz I said, find the slope? Find the slope using 2 points. Maybe I give you 2 points. Well, what I just gave you in this table is 1, 2, 3, 4, 5, like 10 points. Like, I hope you realize that this right here is a point. That is the point 4, 10. And I hope you realize that this right here is a point. That's 5 comma 12.5. So all a table is it's a bunch of points. So I'm going to use 410, and I'm also going to use this because why? I don't want to use decimals. I'm trying to take the easy road. So there are my two coordinates. This is my first x coordinate, my first y. This is my second x and my second y. So if I need to find the slope, which you will definitely be asked to do this, you have to do y2 minus y1. So you have to subtract your y's, change in y, like Ezra said the other day. And then x2 minus x1. So that gives me 5 over 2, which gives me a slope of 2.5. So, price of a donut must be $2.50. I must be at a gourmet donut shop. I did hit a gourmet donut shop in Chicago and got a mango chili donut this summer. Woohoo! Just made my mouth water. Okay, so, yeah, I might ask you to find the slope. That's important. I might ask you to make an equation of a line using these points. Okay, well, do you remember how we make an equation? When we're writing equations, I highly recommend that you use point-slope form. When you're graphing, use slope-intercept form. But when you're making equations, all you got to do is you have your slope over here. I'll switch back to red. You've got your slope over here on the right. And we've got our point right here that I'm putting in the little kind of squiggly box. So we can create our formula, y minus our y value of 10 equals our slope, which is 2.5, x minus our x value of 4. There is our equation right there. We box our answers. Boom. We just wrote an equation for that line in point-slope form. What if then they said, though, graph it? Well, if they said graph it, we would convert to slope-intercept. So we would distribute here. Y minus 10 equals 2.5 times x is 2.5x minus what's 2.5 times negative 4. 4 times 2 is 8. 4 times a half is 2. That's going to be 10. Of course this happened. Now when I add 10 to both sides, this is just because I'm not great at making equations, right? Add 10 to both sides and you get y, that cancels, equals 2.5x, and that cancels. So there's my equation in slope-intercept form, and that's easy to graph. Your starting point would be 0, 0, and then your slope is up 2.5 over 1, up 2.5 over 1. You get the idea, okay? So if I ask you to write if I ask you to find the slope, I'm going to switch to green. If I ask you to find the slope, you need to use this slope formula. If I ask you to make an equation, you need to use point-slope form. If I ask you to graph, you need to switch it to slope-intercept form. What if I said, write an equation of a vertical line that goes through one of the points? Well, remember, let's just pick a random point. Let's use 8, 20. If I ever told you to write an equation of a line that is vertical that goes through that point, well, it would have to be, vertical lines would have to be x equals and then a number. So if it has to go through that point, it's going to be x equals 8, because x equals 8 would be that line right there. Okay, and that's my answer. If I wanted a horizontal line, I'd say y equals 20. That would be a horizontal line that slices through that point. Okay? And the last piece, just to remember, what if you did all this work, you got your equation, and they said write a line that is perpendicular to that line. Do you remember how to do perpendicular? You would do opposite reciprocal. And you might be thinking, what's the reciprocal of 2.5? Well, remember, 2.5 written as a fraction is 5 over 2. So you might have to use your calculator or just your brain and convert it to a fraction, because then the opposite reciprocal would be negative 2/5. So this line right here is perpendicular to that line right there. Okay? That's just a quick linear review. You might have to do all of that stuff. You might have to use the distance formula. Definitely, if you forgot distance formula, go Google that right now. If you forgot midpoint formula, Google that right now. You're welcome. That's all I'll say. All right, it's 10 o'clock. I mean, it's not 10 o'clock. It's 10 minutes down, so I have 5 minutes to go. And I'm going to wrap it up with this. A couple things about functions. Okay, this is literally the fastest function review you've ever seen. We know what y equals x plus 5 is. Okay, we plug in an x, and we add it to 5, and it gives us a y value. Well, we came up with another, mathematicians came up with another notation to represent an equation, and it's used a lot, and that's called function notation. And so if I wrote this, it often looks scary, but it's not. It's literally just saying the function's name. This is the function's name right here. F of x. That is the function's name. It is telling us that if you plug something in here for the x spot, it will spit out a value. Okay? The function is right here. The function is just x plus 5. You don't do anything with this over here. That's just the name of it. Okay? It's useful, though, because we could say, instead of f of x, what if we wanted to find f of 2? Well, what that means is instead of an x being in our function, we put in a 2. So f of 2 is 7. What if we said f of negative 4? Well, instead of an x, we put in a negative 4. And f of negative 4 ends up getting us 1. Okay, so function notation is just kind of a way of organizing your equations, a way of kind of setting up the problem. What if instead of f of x, I said f of x squared minus 2? Well, all I have to do is I have to take x squared minus 2 and replace it in for the x spot of the equation. So my new answer would be x squared minus 2 plus 5, which simplifies down to x squared plus 3. So it doesn't always equal just a number, but it's literally just a notation, a way of writing, where whatever you put into your input position, you plug it into the function and you see what your output is. Okay, function notation. So this is called evaluating functions. Okay, plugging them in, chugging. Let me see, there was one other thing that I wanted to make sure I hit with this. Domain and range. Okay. We'll talk domain, not range. We'll just talk domain for this video, okay? So what does domain mean? Functions have x's and y's. The domain of your function is all of the x values that work in your function. Sometimes x values don't work. Okay, sometimes you can plug something in and it will get you undefined and it won't work. And let me show you the two instances where that happens. Okay, for an equation like this, y equals, let's use function notation, sorry. F of x equals x plus 2. You cannot think of a number to put there that gives us undefined. So literally the domain for those types are negative infinity to positive infinity. Every single value works. But what if I did this? Can you think of a number to plug in for x that would give you undefined? If you said 0, you're correct. 0 would not work here. 2 divided by 0 is undefined. So the domain is actually negative infinity all the way up to 0, but we have to skip 0. Okay, this is called interval notation. You've seen this before, and we'll talk more about it. We had to exclude 0 from that equation. Okay, so if you ever are going to have a number where you divide by 0, you have to take it out. What if this was 2 over x minus 3? What could I not plug in there? I can't plug in a 3, because if I plugged in a 3, it would be 3 minus 3, which is 0. So it would change to this. Okay, and then the last one, I have 10 seconds, so I'm not going to finish it, but we'll pick up tomorrow, is if you ever have a square root like this, you can't have a negative under the radical. There's no such thing as a square root of a negative number. It's imaginary. So imagine, and this is what we'll pick up tomorrow, what if a 0 was there? That would get the square root of negative 2. We will talk about what would happen there, because you're going to have another restriction. Love you guys. Don't forget the on-campus message.